Quantum machine learning with TensorFlow Quantum. Quantum machine learning is an interdisciplinary field that combines principles from quantum physics and machine learning to solve computational tasks. TensorFlow Quantum, or something called as TFQ, is an open source library developed by Google that allows researchers and developers to build and train quantum machine learning models using TensorFlow. The first one, basics of quantum computing. We have qubits, or something that is called as quantum bits, are the fundamental units of quantum information, analogous to classical bits. Unlike classical bits, which can be either 0 or 1, qubits can exist in superposition states representing a combination of both 0 and 1 simultaneously. Quantum gates are the basic building blocks for quantum circuits, similar to classical logical gates. They operate on qubits to perform operations such as rotations, flips, and entanglement. Next, we have quantum circuits. Quantum circuits are composed of a sequence of quantum gates applied to qubits, representing quantum algorithms. The last one is quantum measurement. Its measurement in quantum computing involves extracting classical information from quantum systems. It collapses the quantum state to a classical state. Let's go into quantum machine learning. Now, quantum data encoding is the first part here, which represent classical data into quantum states to leverage the computational advantages of quantum systems. Quantum variational algorithms, on the other hand, employ parameterized quantum circuits (PQC) to perform optimization tasks such as optimization, classification, regression, etc. The last one is quantum neural networks. Quantum neural networks are models that combine classical and quantum layers to perform learning tasks using techniques like quantum gates and parameterized circuits. Let's go into TensorFlow Quantum. Integrating with TensorFlow. So TFQ seamlessly integrates with TensorFlow, allowing users to combine classical and quantum operation within the same computational graph. The quantum circuits as tensors represent quantum circuits as TensorFlow tensors, enabling automatic differentiation and optimization using TensorFlow's gradient-based optimization algorithm. Hybrid classical quantum models. You can build hybrid models that combine classical and quantum components for performing machine learning tasks. We have access to quantum hardware. TFQ provides interfaces to access quantum processors from hardware providers like Google, Cirq, and IBM's Qiskit. The components of TensorFlow Quantum, there are three of them. The first one is circuit library. TFQ provides a library of predefined quantum circuits and gates for building quantum machine learning models. It provides quantum layers, which implement quantum layers such as quantum convolutional layers, quantum pooling layers, and quantum measurement layers for constructing quantum neural networks. Next, we have quantum kernels. They develop custom quantum kernels for performing quantum operations and transformations. The applications of TensorFlow Quantum are quantum generative models. These generate quantum data samples and distributions using variational quantum circuits. The next one is quantum optimization. It solves optimization problems using quantum algorithms and variational quantum eigensolvers. The next one is quantum chemistry. It helps you simulate molecular structures and properties using quantum machine learning techniques. The last one is the quantum circuit learning, which trains quantum circuits to perform classifications, regressions, and other machine learning tasks. Now, if you want to get started with TensorFlow Quantum, you'll first have to install the TensorFlow Quantum and its dependencies. You then have to explore TFQ's tutorial. There's good tutorial and documentation for learning how to build and train these quantum machine learning models. And the last option is to experiment with these quantum circuits, the variational algorithms, and hybrid classical quantum model that we explained using TFQ's APIs and other tools. TensorFlow Quantum provides a powerful platform for researchers and developers to explore and experiment with quantum machine learning techniques, paving the way for integration of quantum computing into mainstream machine learning workflows. However, as quantum hardware is still in its early stages of development, practical application of quantum machine learning may require advancements in hardware technology and algorithms, and the fact that it's very expensive to play with it right now.